Hello, this is Dr. Oz. In this video, I would like to continue going over the market and trade networks 2.1. And in previous videos, went over the PowerPoint or PDF, I should say, for the case study, and then we went over the CSV data files and we created a greedy heuristic Python code. So in this one, I will download the same Python file and create a linear optimization model instead of just a greedy heuristics. So the three dots, download original file, new tab, Colab, and then Google Colab. Open Colab, close the previous tab, upload, browse 15 market trade networks file and files. Wait for it to connect to runtime. Okay, perfect. And upload the CSV files that we download from our Blackboard. Okay. And we did the first part, which is greedy algorithm. Now I would like to go over the second part where it starts from here pip install for the linear optimization model. So I'm waiting for the CSV files to be uploaded first. Still loading, I think so. Okay, perfect. Now first I would like to install the pulp library, which is a linear programming library in Python. This will take a few seconds. Okay, we installed the library. Now next I would like to import pandas, which is like Excel spreadsheet. And then also I will, from Pulp, I will get some of these modules in Pulp. LP problem here creates a linear programming model. And LP maximus help us to maximize the objective function value. LP variable defines decision variables. LP sum is helping us to make those calculations, linear calculations, like sum product kind of calculations efficiently. Value is basically helps us to optimize the values. Um, okay, so we did that. We import those. Now I would like to read those two CSV files and enter them into data frames M and R. M for the market data and R for the RODS data. And then we will split our table into check to see whether the first column is funder or a venture. And we create a copy of this to make sure that we don't mess with the original file. And then we quickly create some dictionaries, base S and D dictionaries. The base dictionary will store all the funders' base return expectations and their names. And S will do the founder's name and the maximum investment amount that the founder can do. And D will do is the venture name and require funding for that venture. Let's run this model. And then next, we would like to go for each combination donor to venture combination. Uh, Basically, it's a edge in our network. We will calculate the profit values based on the returns minus the admin cost per dollar invested. And then we will calculate the dictionaries where we will look at the origin and destination combinations. Origin again here is the funders and destination here is the ventures. And here we'll keep track of the capacities, route capacities, and the profit, unit profit amounts. Use unit profit and cap is the capacity for that route. And here we are using intertuples, which is basically the efficient way to calculate this data based on different rows in our files. And then we build our linear programming. Here is our maximization problem. This is how we do it. We would like to maximize the profit that is uh, our objective function because we would like to profit is something that's great, so we would like to maximize it. And then let's run this model. Here we will create the lower bound, upper bound for our decision variables. Based lower bound, we cannot invest negative amounts. Shorting is not allowed. That's why it's zero. And you can see lower bound zero. And upper bound is depends on the data is given. It cannot exceed based the rod capacity that we have. Perfect. An objective function value is adding up all the decision variables times their corresponding coefficients into profit margins. And then supply constraints. First one is each donor I invest at most their maximum investment amount. So they cannot go beyond SI, maximum investment amount for each donor because they have limited budget. And then another constraint here is demand constraints where we can not exceed the venture capital requirements D sub J. And then this is how we solve the optimization, linear optimization problem using Python. And one means that we found the optimal solution. Now we can extract the results. And here we calculate the flow values in and store them in this F variable. And here we have origin node, destination node, quantity Q that will travel from origin to destination via each edge, and then the unit profit amounts for each of those. And then we will convert all the data frames to CSV files so that we can print our results. And again, we will also not only flow, we would like to also calculate the unused capacities and as well as unsatisfied capital requirements. Again, we don't need, I don't want to go so much in details because they are not responsible for writing these codes from scratch. I just want you to understand what it does. And so basically create another CSV file for leftovers and then another CSV file for unmet demand. And you can see I labeled them as optimal numbers. Flow optimal, leftover optimal, and unmet demand optimal. And then we can run this to show what happened. So basically create three CSV files, one for flow, optimal locations, one for leftover supply for donor money that's not used, and then one for unmet demand. Those are three CSV files, and our solution is 10574, which is better than our greedy algorithm. And if you look at the flows, you can see, well, for example, $18,000 invested by donor 10 to venture 4, and the profit margin there is 7.1 cent on a dollar. And then if you look at the leftover supply optimal, and you can see this is the money that donors still have, but we couldn't allocate because we did not have enough ventures. And you can see that all the ventures are satisfied, so there's no value here. That's it for this video. Until next video, enjoy business analytics.